Our next section is trigonometric ratios. So a trig ratio is an equivalent ratio for corresponding sides. So we have three trig ratios. They're called sine, cosine, and tangent. And it's always of an angle. So they'll always put an angle in there, but then its ratio, it's equal to sides or the hypotenuse. So sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And tangent is the opposite side over the adjacent side. And again, it's all going to be based off these angles that were given. So we'll look at a few examples. And so what people have come up with is a way to remember what goes with what. So it's called SOHCAHTOA. And so it just stands for sine means opposite over hypotenuse. Cosine means adjacent over hypotenuse, and tangent means opposite over adjacent. So it's just a shortcut way to help you remember it. And it obviously doesn't make sense now until we do a few examples. So we're first going to practice just identifying which one to use, how you identify opposite legs, adjacent legs, and the hypotenuse. So we know that the hypotenuse is always across from the right angle. So I know that my hypotenuse is AC. And then from there, I'm going to try to figure out the opposite legs and the adjacent legs. The hypotenuse can never be opposite or adjacent because it's just the hypotenuse. So it's not a leg, it's just the hypotenuse. So it can't be for either opposite or adjacent. So what we're first going to do is says opposite of angle A. So I'm going to put my pointer on angle A. Opposite means across. So if I start here and I go across from angle A, I run into this side here. Well, that is side BC. So the opposite side is BC. And yes, it's two letters because it's a leg, so it has two letters on it. Then if I do adjacent, so again, I'm going to put, it says angle A, so that tells me what angle I'm starting at. Well, I know it can't be the hypotenuse because the hypotenuse is the hypotenuse, but what else forms this angle is AB. So that would be, and I sort of look at it as it's next to it. Some of you might see that it forms the angle right here. So that would make it adjacent. So that's side AB. Then we're going to do the same thing with angle C. I'm going to put my pointer on angle C. Opposite, so I'm going to draw across from it. I run into side AB. And for adjacent, I'm using the same angle, but now I know this is the hypotenuse, so it can't be AC. Adjacent has to help me be next to it or form that angle here. So BC helps form that angle C. So that's how you identify the opposite and adjacent sides. Now we're going to decide if we want to use sine, cosine, or tangent based on the given information. And tomorrow we'll solve these, but just today we're going to work on which one do we choose. So first you have to figure out where is the angle that they are giving you. So in example 1, they give me 50 degrees. Well, that's at angle C. So that means I'm using angle C to determine if I have opposite, adjacent, or the hypotenuse. So I know that I have the hypotenuse because 10 is my hypotenuse. So I have the hypotenuse. And then BC makes this angle here. So that would be adjacent. So I have H and A. So if you come over here to SOHCAHTOA, I have H and A right here. Well, that tells me I'm going to use C, which is cosine. It's a shortcut for cosine. So for example 1, you would use cosine based on that given information. Now example 2, where is the angle the degree is in? It's at angle B. It's right here at angle B. So that's going to be my reference angle. So if I look at B, well, I'm given 3. 3 is across from it. Across is the same as opposite. So I'm given the opposite side. And then this BC is across from the right angle, so that is the hypotenuse. So since I have opposite side and the hypotenuse, that tells me I'm going to use sine. And for example 3, our angle is angle C because it gives you 22 degrees there, so we're using C as our reference. Well, we know that BC is the hypotenuse, so across from this, we have the opposite side, and then AC helps make this angle here, so then we have the adjacent side. And since we have opposite and adjacent, that means I'm going to use tangent here.